Swayam Prabha. Digital India. Educated India.
Okay, welcome again to this series of video lectures on basic surveying, and today we are on module 4, which is on compass surveying. We started it in our previous lecture. So this is the lecture number 2 in compass surveying. Now here in compass surveying, what we have done so far, in our last lecture we talked about the concept of traverse. Because if we need to know about compass surveying, we need to know where we are going to use it. So we need to know about the traverse, because traverse is the thing where we need to measure the angles, and we measure these angles making use of the bearing, and bearings are determined using the compass. So we talked about that why we need the traverse. Then we talked about the types of the traverse. It is open or closed, what they are, what are their advantages, when we can work with these kinds of traverses. Then we discussed the meridian. The meridians could be true meridian, magnetic meridian, or arbitrary, because we make use of these in order to measure the bearings. And the bearings can be represented in two systems. WCB stands for whole circle bearing and quadrantal bearing. We know how we can convert these two bearings also. From one system to other system, we can determine them. And then finally we saw one kind of compass, which is the prismatic compass. We saw the specification of the instrument, how it is made, what are the various parts of it, how we make use of this in the field. Today, before we talk about the other things, we will briefly discuss about another compass, which is the surveyor's compass. Because when you are in the field, you might need to use it sometime. So we should know that what the surveyor's compass is. Then after that, we will see about the local attraction. What is it? Why is it important when we are doing the compass surveying? Then we will run a traverse. How we can do a map with the help of compass surveying. Then we will talk about some corrections, and of course how we can plot our compass traverse. There are a couple of methods. We will look into this bodies method. It is a graphical method for finding the error or error adjustment. Then this is very important and very interesting. We can locate ourselves on a map, or maybe we can locate a point which is marked on the map onto the ground. So these are the things which we will try to see today. Okay, so we will begin with surveyor's compass. We look into some important things of the surveyor's compass. We are not looking at the instrument directly, because prismatic compass is the one which is mostly used in the field. Mostly you will find in the field operations being used. But still we should know about the surveyor's compass. Well, the job is again, we want to measure the bearing here. And what we will do with the surveyor's compass, we will occupy the point A, and we want to measure the bearing of line AB. And there at B, we have a ranging rod. What is there in the surveyor's compass? How it is different than the prismatic compass? Now in this case, all these black lines, this is the body of the compass. The interesting thing here is, along with the body, we have also the graduations. So these graduations are unlike prismatic compass in the body of the compass. In the case of the prismatic compass, these were along with the needle. So there was a ring of the graduations and the needle was fixed to that. While here in this case, the needle is separate. What I mean, if I rotate this prismatic compass, for example here, if you see, if I rotate this prismatic compass here, this particular body, the needle will stay where it is, because needle is pointing in the north direction. That's the direction of north. It will not change its position. Only the compass will rotate, only the graduations will rotate. Now how the graduations are? They are written 0 north, 0 south, 90 degrees east, 90 degrees west. Now you will notice here that east and west, they have exchange their place from our usual way. Why is it so? Otherwise the west should have been here, the east should have been here. It is in order to facilitate reading the observations. Well, what we do now, in order to measure our bearing to point B, what we do, we rotate our instrument. Rotating means this is one vane. This black box here is one vane, which we say the eye vane. You keep your eye here, and this is the object vane. It has got a slit. So a wire here, a wire is here and a slit here. So now using this slit and the wire, we look in the direction of the object for which we want to measure the bearing. So in order to bisect B, we will have to rotate our instrument this way, while the needle will stay where it is. So needle maintains its position. Now what we do, we read the observations in the case of the surveyor's compass against north end of the needle, north end, and that's the north end here. And so we will read the observations here or the graduation here. As you can see over here, the graduation which we will read is from north towards east some particular value. So I can write it as from north, let us say 60 degrees towards east. This is what my compass is showing me. What is there in the area? Well, yes, it is so. Over here, this is north, south, east and west, and in the QB system, in the quadrantal bearing system, the bearing is north to east, whatever is the bearing value, and this is what we are observing here using our instrument. So now you will understand that why the graduations are written in a different way. Well, the next thing which we are going to look at is local attraction. What it is? Because we are talking about, when we are talking about the compass, we should know about the errors of also. What are the errors which could be there in the compass? As we saw in our last lecture, the errors could be, number one, because of the observer. Now in the case of the compass, the errors could be, I hold the compass inclined, so the needle is not free to rotate. I read the observations wrong, so again because of the observer. There could be errors which are because of the instrument. After wear and tear of the instrument, the needle is not free to rotate anymore, or rather it takes a lot of time to adjust. So what is there? Now the error is because of the compass now, or maybe the circle in which the graduations are written, the graduating circle. This graduated circle may have the graduations which are not uniform. So there may be a case because of the instrument also when the errors may come. Finally, because of some external factors which are beyond the control of either instrument or the observer, which we say natural sources. Local attraction is one such source. We are not looking in other errors, but we will look at local attraction in detail. What the local attraction is, at any point, if this is the direction of north, when I say north here now, I mean the magnetic north, because we are talking about the compass. Compass makes use of magnetic meridian, so we are only talking of the magnetic north. If I hang a needle here, the needle should be aligned along this direction. This blue line is the needle, magnetic needle. The meaning of the local attraction is there are some other forces, magnetic forces, which are influencing the magnetic field in this area where we are working. In this particular area, there are some other magnetic forces. What will happen because of that? The Earth's magnetic field is working, some external magnetic fields, some other, maybe a transformer or something, that is also working. So what we will end up with? We will end up with our needle will not point in the north direction, rather it will point in some resultant direction. So this is now the direction. My needle will not hang in the north direction, rather it will hang in some other direction. It will achieve of the equilibrium in this direction because of the resulting forces. Now, if that is the case, we are using a needle like this, or maybe we are working in an area like this particular error here, we say, let us say I write it as E error as local attraction. Now, this local attraction may be also because of some magnetic items which are in my pocket. So, we do not consider those things as the local attraction, because this is something because of the observer. Observer is not the careful person. He should take all these objects away. So, local attraction are basically only for those reasons which are beyond the control of observer. Well, if the local attractions are there, how to take care of that? Can we determine them? Can we determine local attraction? How do we find it that our observations are being affected by it? Well, let us take a case. There is a line A, B, the survey line. We have observed the bearing at A as well as we have taken the bearing at B. And these two bearings, as usual, we say fore bearing and back bearing, because we are moving from A to B. And you know it that the fore bearing minus back bearing should be 180. Well, if it is not so, then you start suspecting there are errors. As we discussed, there are many more sources of the error. Error because of the observer, error because of the instrument, many more sources of the errors are there. So, this not equal to, this could be because of many more reasons, many reasons. But the most prominent one is the local attraction. Or if we consider the observer is very careful, the instrument is correct. There is no problem with the instrument, it has been checked. Observer is also very careful. Then these errors because of the instrument, because of the observer will be very small or negligible within the scope of the work. So, if at all in that case, if this is so, whatever is the error now, it is because of the local attraction. Well, how to determine this, whether the local attraction is there or not, or where it is? So, this gives an indication that yes, there is local attraction in either of these 2 points. How to find it? Let us say we have these 3 lines. We have taken the bearings in all the places. So, we have the fore bearing and back bearing, fore bearing and the back bearing. We find that the fore bearing minus back bearing for this line is not equal to 180, while here fore bearing minus back bearing is equal to 180. If this is so, what is our conclusion? We conclude from here that this station as well as this station are free of the local attraction, because the difference of the bearings is 180. So, if it is so, our conclusion will be, well, this station has got the local attraction because of this. So, we know now, well, our stations here are free of the local attraction, but while this station has the local attraction. And having known this, we can accordingly apply correction for the local attraction, which we will see in a moment. Now, before we go into that, the corrections for the local attraction, let us talk about running a compass traverse. We know traverse. What I will do, I will give you the various steps which we need to follow in the ground in order to run a compass traverse. Well, I will give you a problem. The problem is, again, let us say we have some area, and there in that area we have, for example, a road having some branches there. We also have some houses. Okay, all these are the houses. As you know, this could be any ground. There also are couple of trees. As usual, a ground may be like this, and we want to make a map of this ground, and we want to do it with the traverse, compass traverse. We want to plot the entire boundary of this township, all the roads, all the buildings and all the trees. What the steps should be? Where should we begin with? What should we do? So the very first step in order to make a map will be, as usual, the reconnaissance survey. The recce, or sometimes we say recce survey or reconnaissance survey. What we do, we go to the ground and we observe it. Okay, we can start taking our stations. These are the stations which will be our survey stations, where we are going to form our compass traverse. And let us say the survey lines are like this. There is a closed traverse which we are choosing, as well as there are some further links. Well, this is our idea, the network of the area, by using these control points. So very first step, as you noted, is locating the control points. Now once we are talking about these control points or survey stations, also they are called traverse stations. How should we select them? Does anything come to your mind that, okay, in order to select the traverse stations, we should keep some guidelines in our mind, some precautions. Once you see it, number one, you should be able to measure the distance between the points, because we are going to do the traversing. Traversing means we are going to measure the bearings and we are going to measure the lengths. So if the ground here is undulating, you cannot measure the length. So you should be able to measure the length. So of course here you can see a building. So this line selection is not good. We should select our lines such that they do not pass through the buildings like this. So number one, measuring the length. Number two, all these stations should be in commanding positions so that they can see more of the area. Number three, over here, we have one station here, we have one station here, and in between this is the survey line. The intervisibility is not there, because we need to have intervisibility. Then only I can measure the bearing from this point to this point if we have the intervisibility. So these are the things. And also, for example, let's say we have selected a traverse station here, for this station particularly. This is a very busy junction, and every time the traffic will be there. So we can say, well, this is not really approachable area. It can be approached, but for work, it is not a good area to occupy. So we should select our traverse stations also in those places where we can approach easily, which we can occupy easily, where we can locate our instruments and we can start taking the observations. So all these things we need to take care of, we need to keep in our mind when we are selecting these traverse stations. Well, once the traverse stations are done, the second job is we start measuring these lengths. Okay, I am now selecting a new survey grid, the traverse. Now we have these as traverse stations. So next job will be we start measuring the length and as well as the bearing. How do we do it? We start occupying from A, B, C, D and so on. Is occupying the station A, we occupy A and then we measure the bearing of line AB as well as we measure the length of AB. Now we go to B, we measure the fore bearing of line BC and the back bearing of line BA, and we measure the length BC. Then we go to C, we measure the fore bearing of CD and the length and the back bearing of CB and the length CD. So what we are doing at each survey station, we are taking the observations for fore bearing and back bearing and as well as the length of the line. Again, whenever we are taking the observations, keep in your mind that we do not take only single observations. We should go for multiple observations. you take the bearings multiple times, you measure the length multiple times, maybe once from D to C, then second time from C to D, because we want to ensure that redundancy is there in the observations. Well, once all these things are done, now we want to make a map of this. So whatever observations you have collected, our second job will be plotting of the observation. Now before we plot, what the observations will look like? Let us say for a small traverse, A, B, C, D, where at each place you have taken the bearing, as well as all these bearings are measured, as well as the back bearings, and you have also measured these lengths. So we can write this as, let's say the lines are AB, BC, CD and DA. We can write their fore bearing and back bearing. So the fore bearing, whatever is the value, back bearing of BA, whatever is the value, all these values can be written here. As well as we are writing their lengths, whatever the unit, all these lengths are written there. So this is what is the field observation, the table which you are getting from the field. And whenever we work in the field, ensure one more thing, that we should always have a rough map of the area with us. So in our notebook, we have also a rough map, just a rough map. Okay, that's my rough map. This is how I had taken my A, B, C, D. And then later on, because you are making record of the area, so you are also observing the offsets and other things. So right now we are more concerned about only the traverse, because we already know about the offsets, how to take offsets, how to make use of them. Right now we are concerned about the skeleton of the area, the traverse which we are doing there. So for the traverse, all these will be the observations. Now once these observations are there, what all we can do with these observations? Number one, we need to look for local attraction. Before we go to plot, we cannot plot these observations directly, because these observations may be wrong. Something may be wrong with these observations. So we need to start looking into the errors. Now here in this traverse, if some of the points, for example, let us say B point had the local attraction. If it had the local attraction, what will happen for this line as well as for this line, line AB and line BC, the difference of back bearing and fore bearing will not be 180, while if the line or the station C and D and A, they are free from local attraction, the line AD and line DC will have the difference of back bearing and fore bearing equal to 180, or very near to 180 we can say. So what we do, from these observations we find the differences of back bearing and fore bearing, and we look at this difference. If this difference, as in this case for AB and BC, the difference of fore bearing and back bearing is not equal to 180. So we suspect, yes, at B there is local attraction. Now how to take care of it? How to eliminate this local attraction from the observations? So for doing that, we have to determine the quantity. What is the amount of the local attraction? A, B, C and D, these are the, this is north at every point. Now the differences we have found. Let us say the difference in A and B, the observation of back bearing, or rather fore bearing, because we are moving in this direction AB. This particular value is 120 degrees, while this particular value here, the back bearing, is not equal to it is not equal to 120 plus 180. It is not so. Then whatever is the discrepancy, that is the amount of the local attraction. And we know our A is free of the local attraction because we found the difference of the bearing to line AD, which is the back bearing of line DA, and fore bearing of DA. This is the fore bearing of DA, back bearing of DA. The difference of these two was 180. So we knew that A and D are free of local attraction. So whatever is the local attraction in line AB is because of station B, and so we can locate now if this difference of fore bearing and back bearing of AB is not equal to this particular value 120 plus 180. So whatever is the discrepancy, that is the error at this point, at point B. So what we can do, if for example the value observed at B was 290, let us say. Just for example, we are taking that the value observed at point B, the back bearing of line AB was 290. So we will apply some correction to this because we know that discrepancy. So that amount of correction will be applied here. If we apply this particular correction here, the same correction should also be applicable for in this direction. So this should make the difference of back bearing and fore bearing of line BC again equal to 180. So this is how we are applying the corrections. There is one more method. For example, let us say in a traverse, for none of the lines, the difference of fore bearing and back bearing is 180. For none of the lines. Because in the earlier case, what we are looking for a line, any line in our traverse for which the differences are, the difference is 180. And we assume that both the stations for that line were free from the local attraction. And then we applied the corrections to others. But this may not be the case always. If it is so, none of the lines is free from local attraction. There is some local attraction in each of the lines. What we look for? We look for the least value of this difference. Least value of fore bearing minus back bearing. For which line this is least? Because one of the lines it will be least. So what we do, let us say for example, for this line this value is least. So we start applying correction from this line. If it is least for this, and the difference in back bearing and fore bearing in this case is 182 degrees. Fore bearing minus back bearing. If it is 182 for this line, and this is the least, other some more. So what we do, we equally apply the correction. For example, the discrepancy here is 2 degrees. So we equally apply this correction to both the stations. That means we apply a correction of 1 degree here and 1 degree here. So if we apply the correction of 1 degree here and 1 degree here, what will happen? Now the difference of these fore bearing and back bearing will come out to be 180. Because of course we need to take into account the proper sign, because our aim is we want to make the difference in fore bearing and back bearing of line, whatever this line is, 180. And we know it is not so by 2 degrees. And we are making an assumption that we are going to apply the correction equally at this station and this station. So we want to apply the correction equally. So we will take care of the proper sign, and by applying that we are ensuring now, after applying the corrections to the fore bearing and back bearing of this line, now if you find the difference will be 180. Well, once it is done, we assume now whatever is the fore bearing here, that is correct, whatever is the back bearing here, that is correct, and whatever amount of the correction, for example, because of the local traction, the north was turned in this direction, and this is 1 degree of error. And we know, as we have seen in the previous case, we had applied some corrections here, and we know it is 1 degree. Now there is other line. So the line here, these are the traverse lines. We applied the correction for this one, so this is also free of the local attraction here. Now we want to apply a correction for this. So what we know, at this point the north was required to be rotated this way by 1 degree in order to apply the correction. This is what we have done. So whatever was the bearing observed for this line, because that will be the value. If I delete here this small one, because we are in actual practice, what we are doing, we are observing the bearing from this line. This is the north, or not north, rather the magnetic needle is pointing in this direction because of the local attraction. So we are taking observations, the bearing of this line from here. So for this bearing also, we need to apply the correction as we had done the correction for this line. Because we know at this point the correction is in this direction by this amount. So we will increase this bearing also by whatever is the amount. So if whatever is the back bearing, let us say the back bearing value was theta, so we will do theta plus 1 degree. That will be the new value, the corrected value. Corrected. So we have a corrected back bearing value for this line. Once it has been corrected, we find the difference from now in a traverse. What we had done so far, we started from the least back bearing minus fore bearing line, applied the corrections equally to this and this. Well, now we know the amount of the correction to be applied here. So we applied that correction also to the bearing of this line at this point. Now whatever, after applying the correction, we assume that this bearing is correct because the correction has been applied. Then we find the difference of observed bearing here and the bearing here, and this difference will not be equal to 180, yes. If it is not equal to 180, we apply now correction only to this point, because already correction has been applied here. So we apply the correction only to this point. So now we know what is the amount of the correction which we need to apply at this point, and then so on, we keep going for all other points. So what we achieve by doing this, finally in our traverse, all these lines, their back bearing and fore bearing will differ by 180, and we assume that we have applied the corrections using this particular methodology. Okay, once the corrections have been applied, this is our traverse. What next? After applying the corrections, we can determine these internal angles, because if you know the bearings of all the lines, you can compute these internal angles also. Well, there in the ground, this is very important concept. All these are the traverse stations. If you look there in the ground, these points A, B, C are some physical points. And in the ground, if you draw a traverse passing through all those points, then it's a closed figure, and the sum of internal angles of that traverse should be a particular value, which we say that should be 2n minus 4 times 90 degrees. We know it for a traverse. N is number of the lines here. So for a closed traverse, there in the field is a closed traverse. We know it's a closed traverse. Now, once we can compute these internal angles, because using the bearings these internal angles are computed, then you will find sigma theta. Is it equal to 108, sorry, is it equal to this particular value or not? If it is equal to this particular value, or it deviates from this only by 1500 n minute. In compass surveying, we assume it to be acceptable accuracy. If the difference of, I will write it again, sigma theta minus 2n minus 4 into 90 degrees. If this deviates from 1500 n, this value is less than equal to 1500 n minute over here. This is in minutes. So you convert this also in minutes. The survey is considered to be acceptable, permissible. However, if it is not so, what does it say? Ideally, all these angles should sum to this particular value, but that is not so. So if that is the case, what we need to do? We need to ensure that our angles do sum to this particular value. Because we have done a survey in the field, and the traverse there in the field is a closed traverse. For that closed traverse, this particular condition should satisfy. It's a closed traverse. But what is happening here? Somehow the angles which we have measured are deviating, are having some errors, and the sigma theta of these is not satisfying that it should be equal to 2n minus 4 into 90. It's not satisfying this. These are not equal. So what we need to do? We need to then apply the corrections. We need to do the adjustment. Initially also in our some previous lectures we are talking about the adjustment of the observations. So we need to adjust our observations. Now how do we adjust our observations? Sigma theta minus 2n minus 4 90, whatever is this value is the total value. Let's say I write it as capital E. So that's the total error. So to apply the correction, what we do, we find the sigma theta and 2n minus 4 into 90, where n is again the number of the sides, and the difference of these two, let us say, is capital E. So what it is? Capital E is the total error in angles, internal angles. How to adjust it? Basically this E should have been 0. In ideal case it should have been 0 or very small. We say that E should have been less than equal to 15 under root n for permissible case. If it is more, we are going to adjust. So the adjustment procedure is very simple. For any angle, let us say I write E1 is the error in angle theta 1, then it can be written as the total error divided by number of the sides. So what we are doing basically, this E1 is same as E5, E4, E3 and E2, all are same. We are equally distributing this total error in all the internal angles. There may be some other ways of doing it. You don't want to distribute it equally. You want to distribute by giving some weight. Okay, this particular angle needs to be given more weight, less weight, and you want to distribute this E accordingly. So there will be a different model. But here in this model, the error E is equally being distributed in all. And of course, when you are solving any numerical, when you are doing your laboratory exercise, you have to ensure that you are taking care of the proper sign, so that we want to satisfy this condition. Well, now the next question. The error has been distributed. Can we plot the traverse? What we have done so far, after taking the observations from the field, we came to the laboratory or our office We have applied the correction for local traction by whatever the method. We discussed two methods. And as well as we have now applied the correction in our internal angles. Well, yes, we can plot the traverse now. Because what we have now, for any traverse, if you have all these lengths known as well as their internal angles known, you can apply you can plot it. How we are determining these internal angles? Because we know the bearings from there. Because initially we had measured the bearings, we corrected the bearings for local traction, and then using those corrected bearings, we found the internal angles, applied the correction for closing of the all angles or sum of all angles. We applied the correction for that, and now we can plot it. Whatever the method you can use, if you are using the CAD, you can plot it there in the CAD, you can plot it on your drawing sheet, because you know all these basic things starting from any point. Let us say I can do one plot for you. There in the ground, the traverse was like this, and here in my drawing sheet I want to plot it. If this is my drawing sheet, why I am going to plot this thing for you? Because I am going to give you one more concept, or rather a tradition, a standard. There in the ground, for this line, for example, let us say the bearing was measured as 60 degrees. Now I want to take this ground on my sheet. One thing we must always ensure, whenever we are making a map, ensure that the map is such that for that area the north points towards top. This is important. Always we should ensure this. Now how will ensure this? Well, we know the bearings of the lines. Let us say we take A and B line, and the bearing of this line is 60. So what we do, we start from a point using our rough sketch of the area, and we say, well, the bearing of first line is 60. So we draw a line at 60 degrees, and then later on we know this length of the line, so we cut that length of the line. At this point we know the internal angle, so we can plot the internal angle. Again we can cut a distance after converting it to the scale up to that, and keep doing it, so that you have got a plot. You can make use of the internal angles for plotting it, you can make use of the bearings for plotting it, depending how you want to do it. Now the question is, a big question here, I have shown this plot to be closed. Look at that, we started from here and we reached finally here. So we say this kind of traverse as closed. Now the way we are plotting it right now, will our traverse close? That is the question now. Will it close or not? After doing the plotting the way we have done, we have applied the correction for angles. Yes, our angles are now corrected, and sum of all these angles satisfy the condition there. Because here in this case, if it is n is 5, we know the sum of these internal angles will satisfy the geometric condition of this traverse. But still, will our traverse close after doing the plot? The answer for this is no. Why no? Because so far we have not applied any correction for length. We have applied the corrections only for angles. Because there in the field, all these lengths, they have some relationship to each other. While we are observing these lengths in the field, let us say we committed a big mistake in measuring this length. Despite our all angles being correct now, or we will say adjusted now, our length has got error. So what will happen? This line will come here and this line will end here. So our traverse is not closed. Closed means it's not closed. So what we end up with? We end up with, for any figure in the ground, let us say that was the figure in the ground, what we might end up with, a plotted traverse like this. So, traverse is not closed and there is an error E. So, this error is called the closing error. And this E by P, P is the perimeter of this traverse, is the relative error of the traverse. Generally with the compass we should be able to get a relative error of 1 by 300 to 1 by 600. If we are careful, we should be able to, with the compass and chain or tape, we should be able to get an accuracy like this. So, we have to ensure, yes, if it is too bad, we need to recheck our work, we need to apply the corrections and all this. Well, the problem right now is the traverse here is not closed, as you can see. Ideally, this point should have been here, then the traverse would have closed, something like this, but it is not so. What to do next? Well, next we are going to look into a method which is called Bodice method and also graphical method for applying correction for a condition like that. Now, what is this method? It's a very simple method, and as you are saying, let us say this is a traverse which is not closed. Now, because this traverse is not closed, we started plotting from here A, B, C, D and A dash again. Ideally, this A dash should have been at A dash, but it is not so because of the error. Now, how to apply correction for this? We apply the correction for this by a linear rule, and in that I am drawing it graphically here. What we do, we draw a line equal to the perimeter of the traverse. So, for example, let us say we start from A dash, B dash, C dash, D dash and again A dash. Now, the total error which is there, let us say is E. Now, to apply the correction, it is a very simple graphical method, because mostly when you are doing the plot and you do not have any computing instrument with you, you can do this correction graphically. Now, this A dash to A dash is the perimeter of traverse. E is the total error of misclosure. Now, how to apply the correction? To apply the correction, because we are saying assumption here is we are applying the corrections as per the length, in proportion to the length. So, at B dash, the B dash should move by this amount, which we say, let us say E B, error at B, because this is, you can see just by the similar triangles here, a simple linear rule. Now, the C dash should move, or the correction at C dash is E C, correction at D dash is E D, and correction at A dash is E A. So, what we do, we move this B dash by E B amount, the B dash, and we move it again in the same direction as that of E, because the idea is we want to bring A dash on this A dash. So, to bring it, what we do, we move this by E B. Now, to move this C, because we see the C needs to be moved, or the correction is E C there. However, the point B has already moved by E B amount. So, the total correction at C dash will not be E C, rather from this point to this point, the total correction. So, we move it by this total value. again in the same direction. Similarly, D dash. So finally A dash moves by this amount, and all these points are connected, and the red line here is the corrected traverse, or the correction has been applied and there is no closing error. E is 0 now. So this is just a very simple linear method of applying the correction to our traverse. Okay, now we will see some applications of this compass surveying. Of course, one important application of compass surveying is making the maps or plotting the boundaries. All those things can be done by compass surveying. Some other things which we can do with the compass surveying, here we will see in these different categories. Number one is locating oneself on a map. So first we will see this particular problem. What it is? Locating oneself on a map. Let us say the problem is, I am given a map, and with that map I am there in the ground somewhere. I do not know where exactly I am. Okay, the area may be forest or maybe big field. I do not know exactly where I am on the map. I am standing on the ground with the map in my hand. Okay, let's say, well, as I have shown here, this is a map, and this is the map which is given to us, and we are somewhere in this area, somewhere in this area, but we want to know where we are. We want to locate that point where we are standing on this map. How should we do it? As we know, maps always will point north, will be towards the top. Wherever I am, I do not know, but I want to locate it. The procedure is, standing here, I first locate some permanent points there in the field which are also plotted. For example, let us say I locate a temple or maybe a tower and a tree. These are three permanent things which I can see in the field. I can identify, yes, that tree is there, this tower is there, or this brick kiln is there, or this huge electrical or transmission tower is there. Some of the things which can be located. Having done that, from the point where I am standing, I take bearing using the prismatic compass to these points. To point number 1, I have taken the bearing. Well, this bearing is the forebearing. Wherever I am standing is the forebearing value of that. What I can do, I can compute also the back bearing from that point to me by, adding or subtracting 180. So let us say my first observation was taken for this point, and I found at this point the back bearing was a certain value. That's the value of the back bearing. I can draw a line on my map because I know I didn't observe back bearing. I didn't observe this theta value, rather I determined it using the forebearing. Similarly, for some other object, I take the forebearing, let us say the object is here. So at that object, I had observed the forebearing, and then I compute the back bearing, and the back bearing is this value theta 2, this is theta 1, and I draw the line. So the intersection of these two lines over here is the point where I am standing. Well, in order to ensure that we are doing it correctly, what we do, we observe to some other point also. Let's say this tree, and from this tree again I find the back bearing and draw the line. Now these three lines, I can show these three lines may not meet in a point but in a triangle. So generally we take the centroid of the triangle to be the point where we are. So this is how we can locate ourselves in a map. If this is the case, we can make use of this in order to update a map also. Updating means we have a map, we go to the ground and we want to see, okay, what are the things in the ground which are new but not appearing in the map. Okay, if that is the case, for example here in this ground, we find there is a building but it's not in the map. So what I will do, I will stand on 4 corners of the building and locate those 4 points here. How do I locate? The similar way. Wherever I am standing, I am trying to find that location using the back bearing observations or 4 bearing observations, converting them to the back bearing to 3 well defined points and locating these individual points. The building is located. Finally, we can also make use of this compass in another interesting thing. So far what we are doing, we are locating ourselves. Now what I want to do, in this map there is something, let us say this particular object. I am in the field with this map, and there in the field I want to locate this particular object, where it is. I want to locate that point or this particular feature. Many times this feature you can locate just by sighting also. Well, this is a very high rise tower, you can locate it easily. But if there are 10 such towers, okay, there are 10 such towers here, you are confused. You cannot locate it just by sighting now. You are interested in this particular tower to be located. How to locate it? Of course, the idea will be, first of all, we will locate where we are. Let us say it is located, we are here at this particular point. We will locate ourselves on the map. Once we have located ourselves on the map by the method which we have just done, what we will do now, we will take the 4 bearing, or rather will in our map we will draw a line and we will measure the 4 bearing at this point where we are standing for this object. So that is the value of the 4 bearing which we are computing from the map. We know it that we are here. So we are computing this 4 bearing to a particular tower. Once we know this 4 bearing, next our job will be using this prismatic compass, because in the case of the prismatic compass, while I am seeing through the prism, I can see the graduations, the observations, as well as I can sight the object. So I keep rotating till the observation or the reading here is equal to this 4 bearing value. Once it is so, I am sure now, well, this particular tower is in this line of sight. So then out of those 10 towers, whichever is in this line of sight will ensure that yes, that is the tower in which we are interested. Okay, so what we discussed today, we started our discussions with surveyor's compass. Then we started talking about the errors in the compass, most importantly the local attraction. We also saw that how we can make a compass traverse, that is called running a compass traverse, how to write the observations, then doing the computation. When we are going for the compass traverse, the steps, number 1, reconnaissance, locating the points in the ground, the traverse stations, measuring the bearings, measuring the length of the line, coming to the laboratory, and then looking for the errors, the local attractions, finding those points in the traverse where the local attraction is not there or least, then applying the correction accordingly. After applying the correction for local attraction, we apply the correction for internal angles. They should satisfy a geometric condition. Having done that, we plot the traverse, and after plotting the traverse, you will find that the traverse is not closed. Then we see whether the work which we have just performed was as per the accuracy required or not. If it is not, we might redo the work, or if it is, we will try to adjust the errors. So again, we use the bodice method for adjustment of the errors. So we can apply the corrections that way, our traverse will be adjusted. Well, we also saw some of the applications of the compass, which compass is very useful in military, in adventure sports. People use the compass whenever they are going out in order to locate themselves in a map, in order to locate a point which is there in the field onto the map. So all these things required to be done in order to also locate something which is in the map onto the ground where it is. So all those questions can be answered with the help of the compass. Thank you very much.